Hi, and thanks for tuning in. This is Feeling Colors, investigating cross-modal correspondences between 3D shapes, colors, and emotions. My name is Metatla, and my co-authors are Anna Lin, Meika Scheller, Feng, and Michael Proulx. We're from the Department of Computer Science at the University of Bristol and the Department of Psychology at the University of Bath in the UK. So in this paper, we show evidence for cross-modal correspondences between tangible objects, visual, color, and emotions. We ask people to feel 3D printed shapes and to assign a color and an emotion to their tangible experience. The work is grounded in cross-modal correspondences. These are non-arbitrary perceptual associations between sensory stimuli. They've been extensively studied in areas such as cognitive science or experimental psychology, and numerous examples of cross-modal interactions have been documented. We know, for example, that people often tend to associate larger objects with lower pitch sounds and smaller objects with higher pitch sounds. This particular cross-modal correspondence could have arise from natural correlations of physical properties. For example, that larger objects resonate at a lower frequency and vice versa. But there are other types of cross-modal correspondences that are more abstract and they cannot easily be explained by physical properties. You can try this out for yourself right now. If I was to show you these two shapes on the screen, one angular and jagged shape like a shattered piece of shattered glass, another one is round like a cloud, and then I gave you two random labels, Bouba and Kiki, and asked you to assign one label to each shape. Which one would you assign to which? So the majority of people would assign the label Kiki to the jagged shape and the label Bouba to the round shape. And this is a famous visual linguistic cross-modal correspondence that actually have been shown to hold across a range of age groups, cultures, and so on. So why is this relevant? In short, because in HCI we're interested in multisensory interaction, and it's not only increasingly feasible to incorporate more and more sensory modalities at the user interface, at the user experiences, but it can also be more beneficial to do so. For example, we can improve immersion or engagement or accessibility. What cross-modal correspondences tells us is that we ought to be careful and mindful of cross-modal effects, because the way we perceive and interpret information from one sense can be influenced by information coming from another sense. So in this paper, we wanted to look at the question of whether there are cross-modal correspondences between 3D shapes, color, and emotions, independently of vision. Whether the way we feel objects, tangible objects, combine with color and influence our emotional judgments. So we started off from the Bouba Kiki paradigm with 3D printed Bouba-like and Kiki-like shapes, and we varied them in terms of level of angularity and complexity. So we operationalized this in terms of the number of protruding points on the surface of the 3D printed object. We recruited the 30 participants. We hid the objects away in a box, and so they couldn't see them, and asked them to feel the objects and then choose color from a palette of colors, and also adjust brightness, and also to assign an emotion in terms of an answer to the question, feeling these objects give me a sense of, and then choosing a term that captures the pleasure, arousal, and dominance emotion model. What did we find? Um, uh, in terms of colors, we found that rounder objects and less complex objects tend to be associated with higher brightness and the color blue, and angular objects and more complex objects tend to be associated with lower brightness and the color red. In terms of emotion, we found that rounder and less complex objects tend to be associated with high levels of pleasure, lower levels of arousal, and more of a sense of being in control. Whereas angular and more complex objects were most often associated with lower levels of pleasure, high levels of arousal, and more of a sense of being dominated or having a lack of control. Importantly, these findings contrast those reported from similar studies done with 2D shapes or 2D images. So this means that designers cannot simply extrapolate potential perceptual interpretive experiences that are elicited by 2D images to seemingly similar 3D tangible objects. So other principles are at play, and direct exploration can lead to undesirable outcomes. We extracted four association strategies using thematic analysis. One that often refers to geometric features explicitly, another that refers to familiar objects and familiar experiences, a third that relates to the personal sense of aesthetics or pleasantness, and a final one that looks at the coherence of choice within the boundaries of the experimental procedure itself. So based on these findings, we articulated the design space in the paper to help create tangible multisensory artifacts that can trigger specific emotional percepts. And with this, we think can help provide concrete actionable recommendations on how to exploit cross-model correspondences in HCI. That's it. Thank you.